Price controls are not the only way that the government can affect a market that's in equilibrium. They can also do that through taxes. Now, taxes are the most important method by which governments fund their activities. What we're going to focus on in this section is how per unit taxes, and that is taxes that are assessed as a particular dollar amount on the sale of a good or service, and this is as opposed to a percentage tax, so a percentage of whatever the price of that good is that we're talking about. We're going to focus on how these affect a market that's in equilibrium. What happens to consumer and producer surplus? As an example of a per unit tax, say in 2015, the U.S. federal government imposed an 18.4 cents per gallon tax on U.S. gasoline sales. Let's explore the effect of a tax on the market for a good in practice. Let's look at a market for cigarettes. So with the example on the right, the figure we have here, the market in equilibrium is where the S1 supply curve crosses the demand curve. That's going to be at point A. So the price per pack of cigarettes will be $5, and the equilibrium quantity of cigarettes is going to be 4 billion packs sold. Now, if you levy a $1 per pack tax on cigarettes, that's going to shift back the supply curve up. It's going to go up by $1. So it's going to move from S1 to S2. So the difference at any given quantity between the S1 and the S2 curve is going to be $1. The supply curve is going to shift to the left, or it's going to decrease, because now the producers are forced to pay more with the tax. So it's going to be as if there is a added cost on to producers. If firms are willing to sell 4 billion packs at the price of $5 before the tax, the price needs to be exactly $1 higher in order to convince them to sell 4 billion packs. This is because firms' marginal costs have effectively increased by $1 per unit because of this tax that has been added. A new equilibrium point is going to be at point B. So the quantity sold is going to fall to 3.7 billion packs. And the tax increase is going to cause the price that is paid by consumers to increase to $5.90 per tax. So now producers receive the price of $5.90 per pack, which is at point B, but they're going to have to pay that $1 in tax. So after that tax is imposed and they pay that $1, they end up receiving $1 less, which is $4.90. And that's going to be at the equilibrium quantity of 3.7 billion packs of cigarettes, but where that crosses the initial supply curve. The government is going to receive the tax revenue, which is equal to the green shaded box. So it's going to be the $1 that individuals are paying in tax multiplied by the quantity of cigarettes that are being sold, so the 3.7 billion packs. And that is represented by the green area, the green shaded area, in the figure to the right. Now, some consumer surplus and some producer surplus is going to become tax revenue for the government. And then some of it will become deadweight loss. And this deadweight loss is shown by the yellow shaded regions. They're a little bit harder to see because they're much smaller in this market. So that's the basic idea of how a tax impacts a market in equilibrium, how it shifts the supply curve. So now let's look at another example, incidence of a tax on gasoline. In this example, the market in equilibrium, the price per gallon of gasoline is $2.50, and the equilibrium quantity being sold is 144 billions of gallons per year. So this is where the supply curve, S1, crosses the demand curve, D. So if you add a 10 cent per gallon excise tax on gasoline, that's going to decrease the supply curve. So it's going to shift up the supply curve. The difference between those two supply curves at any given quantity is going to be 10 cents. So it's going to move it up, in this case, from S1 to S2. The price that consumers initially paid was $2.50 per gallon. Now, with the additional 10-cent tax, they're going to end up paying $2.58 a gallon. So where that S2 crosses the demand curve. Now, because there's a 10-cent tax being levied, the producers are not going to receive the entire $2.58. They're going to get 10 cents less, so $2.48. That's going to be where the initial supply curve crosses the quantity now being sold in equilibrium. So in the past, firms are receiving $2.50. and consumers were paying $2.50. Now, after the tax has been imposed, consumers are paying $2.58. The price for them has increased, whereas the firms, in this case the gas stations, are receiving $2.48. So the 10-cent difference that's being levied in the tax. So in this situation, consumers are paying 8 cents of the 10-cent per gallon tax on gasoline, and sellers only paying 2%. While they're both not cutting checks to the government, in this case, the person selling the gasoline, the gas station themselves, are sending in the payment to the government. It's the consumers that bear most of the burden of that tax. So in our example, in this market for gasoline, the buyers effectively paid 80% of that 10-cent per gallon tax, and the sellers paid 20%. This is referred to as a tax incidence. What we mean by tax incidence is the actual division of the burden of a tax between buyers and sellers in a market. So now, what determines this tax incidence? An important observation is it's not whoever has the legal obligation to pay the tax. In this case, the sellers had the legal obligation to pay the tax, yet they only effectively paid 20% of the tax. They only got 20% of the burden. The other 80% of the burden was actually on the buyers. Thus far, we had assumed it was the sellers that were actually physically paying the tax. Let's assume it's the buyers in this case and see what the difference is. So initially, the equilibrium price was $2.50, and at $2.50 per gallon, there were 144 billion gallons of gasoline being sold per year. So the same exact equilibrium condition as before, we have the same exact initial supply and demand curves. If the buyers have the legal obligation to pay the 10-cent tax on gasoline, everything is going to remain the same. What's going to happen is the demand curve is going to decrease. It's going to shift down, and the difference at each quantity between the original demand curve D1 and the new demand curve D2 is going to be 10 cents, the amount of the tax. So now if you look where the new demand curve D2 crosses the supply curve, the price is going to be $2.48 per gallon. And if you take that quantity, the 140 billion gallons of gasoline sold per year, and take that up to the initial demand curve, it's going to cross that demand curve at $2.58. So we still have the consumers paying $2.58, and we have the sellers receiving $2.48 after the tax. So we end up with the same results. It does not matter who legally has to pay the tax. What matters is the slope of the supply and demand curves. So the tax incidence is determined by the relative slopes of the supply and demand curves. A steep demand curve means that buyers do not change how much they buy when the price changes, or at least they don't change it by very much. This results in them taking much more of the burden of the tax. On the other hand, a shallow demand curve means that buyers change how much they buy quite a bit when the price changes. Then they could not be forced to accept as much of the burden of the tax. And there's a similar analysis for sellers. Now let's look at one final example about how taxes impact market and equilibrium. And we'll look at the burden of the Social Security tax. With the Federal Insurance Contribution Act, FICA, the tax is 15.3% of wages, and it helps fund Social Security and Medicare. By law, employers pay half and workers pay half of that 15.3%. And that's taken out of your paycheck. Every single paycheck you receive, you get that tax taken out. So now let's explore who really ends up paying most of the burden of this tax. The answer is going to depend on who is less sensitive to changes in wages. Is it going to be employers, in this case the buyers of labor? There's going to be workers, who are the sellers of labor. Workers are relatively insensitive to their wages. And what I mean by that is they don't change their amount of hours worked, that decision, very much when their wages change. They tend to work the same amount of hours no matter what their wages are. So workers end up with most of the burden of this tax. So now let's use our model of supply and demand to explore what exactly happens. So the panel on the right illustrates an imaginary $1 per hour Social Security tax. So now you can see between the two, whether firms or workers have the legal obligation to pay the tax, workers end up with most of the tax burden. So let's look at the first panel. In this case, Social Security tax is paid by employers. So what that's going to do is reduce the demand for labor because you're increasing the cost of labor. That's going to shift the demand curve down, and it will shift it down for $1 at between every single quantity. So in this example that they're showing, the Social Security tax, the amount that's paid by employers, is only going to be 5 cents, so 5% of it, whereas 95% of it is going to be paid by the employees. Looking at the other panel, the right panel, this is when Social Security tax is paid by the workers. A $1 Social Security tax is going to decrease the supply. It's going to shift it up by, again, $1. So at any quantity, it's going to be $1 higher than it was in the previous supply curve without the tax. We end up with the same result, that 5% of the tax is being covered by employers and 95% of it is being covered by the employees themselves.